Bismillah ar-Rahman ar-Rahim. Welcome to a new lesson in SAT, and our lesson today is the quadratic functions or the quadratic equation, how we can represent the quadratic equation, how we can find the vertex. Before we go through our lesson, we should know that I have three forms for the quadratic equations or the quadratic functions. The three forms are the standard form, ax squared plus bx plus c, the vertex form, a multiplied by x minus h squared plus k, and the x-intercept form, y is equal ax minus 1, x minus n, times x minus n. So I have three forms, and it's very important to understand the difference between these three forms. Again, the first one is the standard form, ax squared plus bx plus c. The second is called the vertex form, and why is that? Because it gives me the vertex. And the third one is the x-intercept form, or we called it the intercept form, and its form is ax minus n times x minus n. We are going to study each form one by one, and how to find the vertex, how to sketch the graph, how to find the x-intercept and the y-intercept. But before we go through it, we should know two important things. The graph of the quadratic function is presented by a parabola open upward or open downward. If it's open upward, it has a vertex here, which is represented by a minimum point or a minimum value. And if it's open downward, its vertex is maximum value. How I can decide if it's open upward or open downward? The value of A decided that for you. If it's in the standard form and the value of A is positive, so it's open upward. If it's the value of A is negative, it's open downward. In case of open upward, the vertex here is represent a minimum point. In case A is negative value, and I mean by negative, it could be -1, it could be -2, it could be -3, it could be any number which is negative. It's open downward, so the point is a maximum point. Again, if the value of A is positive, the parabola is open upward and it has a minimum point. If A is negative, it's open downward and the parabola has a maximum point. So this is the first thing you need to know about the three forms. What we are going to study about the three forms, and let's study with the first one, the standard form ax squared plus bx plus c. We need to understand how to find the vertex of this form, how to find the x-intercept, how to find the y-intercept. Again, how to find the vertex of this form. And to find the vertex of this form, it's any vertex is consist of x and y. X is equal to -b over 2a, and y is the replacement value of -b over 2a. Again, the vertex form, x is equal -b over 2a, where is b is the coefficient of x, and a is the coefficient of x squared. And by replacing the value of x into the function, I will find the value of y. So this is how to find the vertex. And then to find the y-intercept is the value c. So c here give me the y-intercept. These are the rules. But what about the first example? First example here is asking about the vertex and asking about the y-intercept and asking about the x-intercept. Asking about the vertex and the y-intercept and the x-intercept. Listen carefully so you can solve the second example. First, the form is in the form of f of x is equal ax squared plus bx plus c. So the first thing I'm going to do is to define the value of a, which is equal to 2 here, the value of b, which is equal to -4, and the value of c, which is equal to 1. And from the value of c, I know that the curve intersect the y-axis at the point 0 and 1. So from the point C, I know that it's intersection point with the y-axis point. What about the value of A? A is positive. And since A is positive, so the curve is open upward, and the vertex here represents the minimum point. So A is positive, open upward, and has a minimum point. Let's find it. To find the vertex or the minimum point X and Y, first I'm going to replace X with negative B over 2A. So X is equal negative 4 over 2 times 2. So it's equal to 4 over 4, which is equal to 1. So the value of X is equal to 1. Then if I wanted to find the value of Y, I'm going to replace X here with 1. So 2 multiplied by 1 square minus 4 multiplied by 1 plus 1. So it's 2 minus 4 plus 1, which is equal to negative 1. So the vertex is 1 and the negative 1. Let's do a small sketch. The point of the y-intercept is 1. Here is the point 1. Here is the point negative 1. So here is the vertex. Letter U. Has a minimum point. So I still have here x1 and x2, the intersection point with the x-axis, the intersection point with the x-axis. And it's not necessary in all the questions of SAT to find the intersection point with the x-axis, but to find the intersection point with the x-axis, all what you have to do is to apply the quadratic formula or apply the factorization method to solve this equation. So I'm going to solve the equation of second degree by the quadratic formula, or I'm going to solve the equation of second degree by factorization. And it's clear for us that this one is by quadratic formula. You have a video for how to use the quadratic formula. The quadratic formula is negative b plus or minus root b squared minus 4ac divided by 2a. So x is equal negative b, which is going to be positive 4, plus or minus root b squared, which is negative 4 squared 16, minus 4 by 2, which is a, by c, which is equal to 1, divided by 2 by 2. So it's equal to 4 plus or minus root of 4 by 2 is 8, 16 minus 8 is 8, divided by 4. So it's equal 4 divided 4 is 1, plus or minus root is going to be divided by 16, so it's going to be 2 root 2, so it's going to be half root 2. So it's going to be 1 plus or minus half root 2, half root 2. It's not necessary, as I said, in all the question to figure out the values of x1 and x2, the intersection point with the x-axis. But it's very important to find the y-intersection and to find the vertex and to define if the vertex is minimum or maximum. Regarding the second example, and why we're still working with the first form of the quadratic functions, ax squared plus bx plus c. I wanted to find the vertex, I wanted to find the y-intercept, I wanted to find the x-intercept. To find the vertex is x and y, and x is equal negative b over 2a, and y is equal f of negative b over 2a. Y-intercept is the value of c, and the x-intercept, I can use the quadratic formula. X is equal negative b plus or minus b squared minus 4ac divided by 2a. So a here is equal to negative 1, b is equal to 8, and c is equal to negative 2. So to find the vertex, and notice that this function is open downward and it has a maximum value. Why is that, Mr. Hisham? Since the value of a is negative, since a is smaller than 0, so it's open downward and the vertex is maximum. So x is equal negative b, which is negative 8, divided by 2 multiplied by negative 1. And 8 multiplied by negative is negative 8 divided by negative 2, which is equal to 4. After I figure out the 4, I go back and I replace it here instead of x. So it's negative 4 squared plus 8 multiplied by 4 minus 2, which is negative 16 plus 32 minus 2. So it's 32 minus 18, which is equal to 14. So I know now that the vertex of this curve is 4 and 14. The y-intercept is 0 and negative 2, the value of c. If you want to just to do a sketch, a small sketch of this function, you will figure out 4, 1, 2, 3, 4, and 14 is up there, and the point negative 2 is here. So approximately the curve is like this. As a sketching, it's not passing through the origin, okay? So here is x1 and x2. If I wanted to find x1 and x2, but it's not necessary right now, but if you wanted to find them, you are going to make the whole equation negative x squared plus 8x minus 2 equal to 0. And by using the quadratic formula, I wrote it here, negative b, so it's negative 8 plus or minus 8 squared, which is 64, minus 4 by a by c over 2 by a. So it's negative 8 plus or minus root 64. Negative by negative is positive, by negative is negative. So it's a 64 minus 8, which is equal to 54 minus 8, 56, divided by negative 2. So x1, I can write it as negative 8 plus root 56 over negative 2. I think this is minus. And x2, because it's the far away one, negative 8 plus root 56 over negative 2. This is, I didn't simplify it because it's not necessary right now. For me, I'm not discussing the quadratic formula. You can go back to the video of the quadratic formula and to learn from there how to simplify the form of the quadratic equation. Now, let's go to the second form of the quadratic equation, and we called it vertex form. Vertex form is the function ax minus h squared plus k, where the vertex directly is the number beside x in the bracket and the number outside, which is k. So directly I have the vertex. But if I wanted to find the y-intercept of this function, I'm going to replace the x in the function with 0. And if I want to find the x-intercept, I will make the equation equal to 0. Again, if I wanted to find the y-intercept, in the last form it was c, but here it's not k. I'm going to replace x with 0. But if I wanted to find the x-intercept, I'm going to replace y with 0. So why we called it vertex form? Because it's directly I can find the vertex. Vertex x minus 1, if I make it x minus 1 equal to 0, so x is equal to 1. So h is 1. And I put down the positive 2. This function, the coefficient is negative. So a is negative. So it's open downward and it has a maximum value. So I figure out the vertex, but I need to find the y-intercept. To find the y-intercept, I will say that y is equal negative, replacing x with 0, plus 3. So it's negative. Negative 1 squared is 1, plus 3, so it's equal to 2. So the y-intercept is 0 and 2. And to find the x-intercept here, I will make the whole equation negative x minus 1 squared plus 3 equal to 0. Listen carefully how I will solve this equation, because I'm going to use the completing the square. This is negative. Positive will move to the other side, negative. Divided by negative 1, divided by negative 1. So x minus 1 squared is equal to 3. By taking the square to the other side, so x minus 1 is equal to root 3 or x minus 1 is equal to negative root 3. So x here is equal 1 plus root 3, and x there is equal 1 minus root 3. Let's try to sketch this function. The intersection point with the y-axis is 0 and 2. Here is the origin. The vertex is 1 and 3 and open downward. Okay, sorry for my graphing. This is the vertex, 1 and 3. Here is the y-intercept at 2 or 0 and 2. The point here is 1 minus root 3, and the point there is 1 plus root 3. So I didn't use the quadratic formula to find the x-intercept here. It's not necessary to define the x-intercept while you are solving the vertex and the y-intercept, but I would like to show it to you how to find the x-intercepts. As we can see, I'm asking about the vertex and the y-intercept and the x-intercept of the given function. And as we can see, this is in the form of f of x is equal ax minus ah squared plus k. So the vertex directly, I'm going to change the sign of the number beside the 3, so it's going to be negative 3, and taking the number outside, which is negative 4. This parabola is open upward. Why it's open upward? Because a here is positive, so it has a minimum point. So I am looking right now for the y-intercept. So I'm going to replace x with 0. Three squared is 9, minus 4 is equal to 14. So the y-intercept is 14, or 0 and 14. Here is the y-axis. Here is the point 14. Here is the vertex 1, 2, 3, negative 3, and 1, 2, 3, 4, negative 4, so it's somewhere here. So I'm going to sketch a parabola. This parabola will intersect the x-axis at the point x1 and at the point x2. I can figure out the values of x1 and x2 by making this equation 2x plus 3 squared minus 4 equal to 0. So 2x plus 3 squared is equal to 4, divided both sides by 2. So x plus 3 squared is equal to 2. So x plus 3 is equal positive of root 2, or x plus 3 is equal negative of root 2. So x is equal root 2 minus 3, or x is equal negative root 2 minus 3. Notice that. Now we have the third form of the quadratic function, or the quadratic equation y is equal ax minus l times x minus l. So as we can see here, if the coefficient a is positive, so it's open upward. If a is positive, greater than 0. If a is negative, smaller than 0, then it's open downward. And x minus 1 and x minus m directly give me the intercepts of x-axis. So the first form have the y-intercept. The second form has the vertex itself. The third form have the x-intercepts, and the x-intercepts here are L and M. And don't forget to change the sign. If this sign is negative, so L is positive. If this sign is positive, so L is negative. How to find the vertex in this case? Any vertex is consists of x and y. To find the value of x, it's the midpoint between L and M. And to find y, I'm going to replace the value of x into the function. I'm going to replace the value of x into the function. Let's go directly to one example. Here, he is saying, find the coordinates of the vertex, x and y. Find the value of the y-intercept, find the value of x-intercept. Let me remind you that if I wanted to find the value of the y-intercept, I am replacing x with 0. And to find the x-intercept, in this case, this is the easiest one because I have the x-intercept directly. I prefer, while you are solving the third form, is to start by sketching. Here, I don't have a here is equal to 1, so these functions open upward and have a minimum point. X minus 2 is equal to 0, it means that x is equal to 2. And x plus 3 is equal to 0, it means that x is equal to negative 3. So here is the point 2, 1, 2. Here is the point negative 3. And the function is open upward. So the vertex is the midpoint between 2 and negative 3. So to find the x coordinates, I'm going to add them, 2 plus negative 3, and divide the value by 2. So it's negative half. So the vertex here at negative half. And to find the y-intercept, sorry, the y of the vertex, y coordinates of the vertex, I'm going to replace x with negative half. So negative half minus 2 multiply negative half plus 3. Negative half minus 2 is negative 5 over 2. Of course, you can use calculator in this part. And positive 5 over 2. So it's negative 25 over 4. So the vertex is negative half as negative and negative 25 over 4. Now, as we can see, I have the y-intercept. How I can find the y-intercept? By replacing x with 0. So 0 minus 2 multiply 0 plus 3. So it's negative 2 multiplied by 3, which is equal to negative 6. So the y-intercept is 0 and negative 6. So as we can see, I figured out the x and y-intercepts easily by using this form. And this form is called the X-intercept form. Another questions in the third form of the quadratic function, how to find the vertex, how to find the y-intercept, x-intercept of a quadratic function in the form of y is equal a x minus l multiplied by x minus l. It's clear for us here that I have two values for x. X is equal negative 5 and x is equal positive 1. So by drawing a small sketch, here is the x-axis, here is the y-axis. The point 1 is here. And the point negative 5 is there. And the parabola here is open downward. Why it's open downward? Because the coefficient here is negative. So it has a maximum value. Okay, so I'm sure that the function is drawing like this. So the vertex is somewhere here. To find the vertex x and y, the coordinates of the vertex, x is equal the sum of the two values divided by 2. So it's equal to negative 2. So it's equal to what? Negative 2. So here is the vertex. Its x coordinates is negative 2. To find the y coordinates, I'm going to replace negative 2 by x. So negative 2 plus 5 multiply negative 2 minus 1, which is equal to negative 3 multiplied by 3 multiplied by negative 3. So it's negative 27. So the vertex is negative 2 and negative 27. How I can find the y-intercept point? I can find the y-intercept point by replacing x with 0. So it's negative 3 multiplied by 5 multiplied by negative 1, which is equal to positive 50. I have a mistake. Yes, my mistake is this is positive 27. So positive 27. So, and this point is equal to 50. How come this point is negative 27? Sorry, teachers do mistakes sometimes. Barakallahu feekum, these was the three forms of the quadratic functions.